Okay, Assalamualaikum warahmatullahi wabarakatuh. So firstly, I introduce myself. My name is Abdul Muiz Rahim. My matrix number is CE210-177. So I would like to present my part is introduction. So the introduction is our aim is to perform the circuit analysis technique for a given network problem using a suitable simulation approach. So students should respond and reflect their understanding on the implementation of various circuit analysis technique to solve the problem. So our objective is to solve the current and or voltage response of a second order circuit. Second one is to solve steady state expression using various circuit analysis technique. So the other one is to simulate second order circuit and steady state current voltage, and to demonstrate the second order circuit and steady state analysis or simulation.
Assalamualaikum. My name is Muhammad Amin Hazim bin Azam with matric number CE210145. I will explain and make all demonstration of the simulation that we do from this experiment. So first we go to the first question. In question C, it asks us to simulate the circuit to plot the response graph. So we use multisim to simulate it. So this is a 3 circuit for the question 1. First circuit is critically dampened, which is we use 10 ohm for this circuit, and this is a 3 level that connected with capacitor for this circuit. Okay, go to the next circuit. This is a over-damped circuit, which is we use 5 ohm for this circuit, and this 5 in the wire is connected to the circuit that we will find the graph from this connection. And the last one is under-damped circuit, which is we use 20 ohm resistor for this circuit, and for the level is 7 in the wire. So for simulate the graph, we use analysis, transients analysis. Okay. For the output, we just add all the output that we want to find, which is V3, V5, V7 and current. So we just simulate it same time. The graph will stop until 1 second in the simulation. So we just wait for the few seconds to get the static graph. Okay, the graph already stopped. So we zoom to the first graph to make analysis of this graph. Okay, this is our graph in the experiment. So that we can see a green graph, red graph and purple graph. For the blue graph is current, which is the same for the all circuit. And the next one, green graph is under-damped graph. Red is critically damped graph, and the last one, purple, is over-damped graph. So we run again with one output. Simulate, analysis and transients analysis. So first we want to know the V3, which is critically damped. So we remove V5 and V7. Okay, simulate. Wait a few seconds. Okay, complete. So we zoom to make analysis. Okay, this is a first graph, which is critically damped graph. Okay, next we make a simulation for over-damped graph. So over-damped graph is V5. So we add and remove V3. Okay, simulate. Wait until 1 second. Okay, we zoom to make analysis. This is a over-dampened graph, which is the second circuit. Okay, we make a simulation for the last circuit, which is under-dampened circuit. Transient analysis, output, and we change to V7 and remove V5. Okay, simulate it. We wait until 1 second. Okay, the graph already stopped and we zoom. Okay, we can see the under-dampened graph for this circuit.
Okay, hello, my name is Emerson Rasane and my lecture number is CE210029. Okay, today I would like to present about calculation for question 1 and question 2. Okay, first I will do explanation about question 1. Okay, for the question 1, we need to design a circuit that to obtain an overdamped, critically damped, and underdamped. The range 200 until 1000. So we choose for 1000. Okay, as you can see, after I calculate formula, I get the C is capacitor is 50 microfarad, and then for inductor I got 20 millihash, and then after I got that for S1, then this is the equation 1. Then VC V total, this is the V total, and then this is 480. So this is the for A2. So from here we need to change the A2 to the negative 4480 here, exponent negative 100 ampere. So this is IL or critically damped. So for overdamped, so the WO or omega is still the same, and then for R is 5. We use 5 uh 5 ohm, and then this one I get it from the calculation for the critically damped from the first one here and here. This is the inductor. So that S1 S2. So because this have a this is a positive, we call positive in the or in the square root. So we can calculate S1 and S2 here and then change it here. I exponent. The answer is A2. And then let this be a equation 1. And then after that for the this one is the formula for VC T. And then this one you can take it from this one. 10 this means we got it from this one, from the equation 10 volt here, insert it here, and then you find that this is the answer for the A2. Swap it into 1. So this one is A1. So this is the final answer for underdamped. So this is the underdamped. Underdamped as usual. The R is 20. For this one, the R is 5. Okay. For this one is R equal to 20. Okay, 20. Then because this one is we will get a negative in the square root, so it have imaginary number here. So you need to do a WA. You need to calculate the WA. So the WA is equal with this answer because we will get the same. Again for A1, the one is and it will like A1. So this one DI, DT, DIT as usual. Just let it be. And then this is VCT and then that's all. And then you will get A2 for 0.024. Okay, so that's all for the calculation for question 1. Question 2, this one is question 2. As you can formula here, so it will not make any confuse when you do. In the question, we need to do with the two circuit analysis technique, either this nodal, mesh, source transformation, and others. So I select nodal analysis and mesh analysis. Okay, for nodal analysis, this is I get from node 1. Node 1 is here. Node 1 is here. And then I got the V3 equal to negative 49.0655 minus 0 at 10.11. I is imaginary number. And then multiply by V1 minus 500 plus negative 100i. And for node 3, this is the equation. For not 4. Node 4 is here. This is node 3. This is node 4 that I get. And then V1 here, V1 is V3 equal to this, and then V3 equal to something else. And then I put it in the, after I calculate here, this equation, so it become like this, simplified like this. And also it will get like this also. And then the equation for V4 is also like this. So after that, I just calculate it by calculator, and then I got this one, negative 10.0057 plus 0.3823 imaginary I. So after I calculate it, I change it to the polar, so it becomes 10.008. So this is the degree. And then for the V3, negative 7.217 minus 11.209 imagery. So after I calculate it, after I change it to the polar, and I will get this answer, 10.44 negative. For the degree is negative 125.495 degree. Okay, for V4, the number that I get is, I calculate here using calculator. The answer that I get is 48.483 and minus 42.5491 imagery. So the final answer is 64.506 imagery degree negative 41.37 degree volt. Yeah. For the IA is uh, current in A. It means it's in here. Here B and then C. In a capacitor, inductor, resistor and capacitor, right? Inductor, capacitor. I'm sorry. Then this one is in the inductor, current in the inductor. So I calculate here, and then this is the final answer, 10.008, 8.684 degree ampere. So for IB is IR2. IR2 is the current in resistor 2. Resistor 2 in 5, I think. Yes, in 5 ohms. So you calculate here, and then you get the final answer, 2.688 degree negative 125 down to 3.495 degree ampere. So for the IC means I in capacitor 2. So I calculate here, and then this is the final answer for the IC2, current in capacitor 2. And then for the V total is same with V4. V in node 4. V in node 4. So as you can see, V in node 4 is this one. So you can use that to calculate here, put it here, and then the answer is become this one. Let's get the same answer as before. For the second method, I use a mesh analysis. So I do mesh 1, mesh 2, and mesh 3 here. And this is IA, the current of IB, IC, and then this is 1A, this one is IR3. And take the mesh analysis one, mesh 1 here. Okay, it's L1 I plus L1 I1 minus IA bracket R1 minus AX C1 plus AB R2 equal to 0, and then I enter the what do you call that? Enter the value. So the value for IA is 0.38 plus 9.997 imagery. So this one mesh for mesh 2 also. I take the mesh 2 in the mesh 2 here. So the answer for the IB is negative 1.55 minus 2.3391 I. For mesh 3 is what I get from the here. And then after that, I got the C is left accordingly because this one get the IC here. So 4.016 plus 4.570 imagery. So as usual, I put it in the here. So in using a metric form, I just what do you call it? I just calculate it using the polar and using polar and calculator. So I got this one. So as you can see, the IA using mesh is exactly the same with the IA. These have a little differences, but it can be acceptable as you can see. And then the IB also you get 2.0809. And then IB for this one, 2.668. But the degree is not the same. As you can see, this you get the same answer, right? Now this one, 6.084. 6.084. It's not get the 6, but 5.8 is almost the same with the C. And then the V total for using mesh is you get 61.6. It's a little bit different, just 3 volts, but it's acceptable, right? So that's all for me.
Number 2, for question B, it allows to simulate a steady state current and voltage IA, IB, and IC. Compare the result with the calculation. So first, we choose multisim, and this is our circuit given in the question. So we use single frequency AC output. For the output, we add I capacitor, IC2, which is I that through C cap2, And next is inductor, I with inductor, and the last one I that through resistor. And this is R that through voltage. We run it. Okay, this is a value that we get from the simulation, and the value is same with the calculation. So we get the true answer. And next question is asked us to find the step response. So we use the same method with question 1, transient analysis and output. The output is the same with the previous question. So this is all of the graph we get from the circuit. So we want to find the VT graph. So we turn off all, and this is a VT graph. Okay, next is current is true with capacitor. This is the graph. And next is the current that through resistor. And the last one, which is IA. This is the current that through inductor. So that's all from me. Thank you.
Okay, we proceed to the conclusion. In conclusion, we have managed to do the calculation for different types of circuit, which is overdam, underdam, and critical dam for question 1. So we are also able to obtain the respective graph for each type of circuit. With the help of multi-sim software, it is quite easy to obtain this graph by using Trizen graph simulation. Each Trizen graph give a different type of output due to different type of circuit. For the question 2, we also managed to do the calculation to the value of IA, IB, IC, and VT. Then the simulation was also done using multi-sim software. Throughout the project, we have learned about how to apply your knowledge, which we gain through the course to find a solution for respective circuit, and also how to use the multi-sim software for the simulation. Okay, thank you.